Kelvin Beluku, and I will explain the project of earthquake-resistant buildings. Earthquakes have always been a serious problem for us. They cause damages in nature, affect climate, but most important, they threaten human life. In my project, I propose a new application in civil engineering that consists of the combination of three materials: the use of Teflon, the construction of a pool at the top of the building, and the use of compression strings. So what is an earthquake? An earthquake happens when two blocks of the earth suddenly slip past each other. The surface where they slip is called the fault plane. Also, we know that Albania is known for a high rate of seismicity, so even Thumanas earthquake was very dangerous. Pendulum. When an earthquake begins, it pushes the structure of a tall building to the direction of the seismic activity. The top of the building is left motionless for a moment, so this results in damage. Pendulums are installed on the upper floors to prevent this, and we are using our pool as a pendulum. Due to the inertia and counteracting force of the earthquake, the waves will sway the opposite direction, so the building will be stabilized. Maybe it can be a little bit expensive to install the pool at the upper floor, but we are going to use it as a source of money. Kinetic friction, it always opposes a sliding motion and tries to reduce the speed at which the surfaces slide across each other. An example for this is Teflon, that there is no friction at all. So why I use Teflon? The buildings is stated in Teflon plates because Teflon plates eliminate friction. Also, Teflon can resist the temperatures from -100°F to 500°F. It easily resists abrasion, it is non-porous, but also there are advantages for both us and the environment because Teflon is not too expensive and it is recyclable. Compression springs are the most common type of springs. They are used to keep things apart, while tension springs are used to keep things together. So we all know that after the earthquake the building won't shift back at its first position, so compression springs are going to shift the building back. Also, some part of the earthquake's energy is going to be transmitted to the compression springs, so there will be less damages to our building and our building will be amortized. Ductility. Ductility is the ability of the structure to sustain its load and dissipate energy for several load cycles after initial yield without being collapsed. As we can see in the graph, the brittle is going to collapse after it reaches its elastic limit, so the ductile performance is better. I did 3 measurements. The first one was with no Teflon and no pool, the second one was only with Teflon, and the third one was with both Teflon and the pool filled with water. So I measured the period of the motion, the displacement of the structure and the building, I calculated the energy and the relative displacement. So here are some period calculations that I did. The displacement graphs and the energy graphs that I calculated from their formula. So in conclusion, in my project I proposed a new solution to this problem. After having the results, it is crystal clear that we can take this project for seriously, or why not make improvements or welcome them. During the experimental part, I took merit of the period using a gate timer, so I can say that those measurements are pretty accurate, while the displacement was measured using a rail system with gauge, which could have led me to some small deviations, but those deviations didn't prevent me from getting correct results. Follow me because I will show you how this experiment works. The materials I used for the project are harmonic oscillator with electric motor, a plastic cup, the structure that acts like the Earth's tectonic plates, compression strings, the power supply and the gate timer. Now I will demonstrate how this project works.